Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's question is in front of you. I request please pause the video and try by yourself. So let's start the discussion. So now question, this is a trifluorobenzene, means it's a fluoro analog of toluene. This oxidation under drastic condition and followed by workup. What is the product? 4 options are provided. One of them is the right answer. Let's discuss. So actually, if you oxidize this trifluoro means this toluene analog, means this is actually toluene. Okay, so trifluoromethyl toluene, and if you oxidize this substance of alkaline KMnO4 heat, it produces trifluoroacetic acid. Okay, this is one of the methods to prepare this trifluoroacetic acid. By the way, I have already discussed a dedicated lecture on the preparation of trifluoroacetic acid. You may visit for better understanding. So this is trifluoroacetic acid. This molecule is very unique because of its exceptional stability due to the presence of this 3 fluorine atom. Okay, that's why the conjugate base produced from here is stabilized more because of the withdrawing effect, or better to say the withdrawing effect of this CF3 group, you can also say like that. Okay, so this is the uniqueness, but the main interesting point rises if you oxidize this toluene in terms of KMnO4, it produces this molecule which is known as benzoic acid, and the concept is called as side chain oxidation. I have already discussed this concept in details in a dedicated video for carboxylic acid preparation. This side chain oxidation concept is useful for preparation of aromatic acid. Why? Because in side chain anything, for example in this case you have taken toluene, instead of that if you have taken this ethyl benzene and do the same thing, you will ultimately end up this toluene, because this is a side chain oxidation. The side chain will oxidize. Now the question, why this reaction happened? Means the side chain oxidation we have understood, but in this case in fluorine derivative, means what is the role of this CF bond or the bond energy of CF bond? In that case the CF bond didn't break, but if you look at this molecule very carefully, this other part is broken. Phi. Actually the CF bond, if you look at this CF bond, is one of the strongest covalent bond in strongest covalent bond or carbon fluorine bond. That's why this doesn't break here. Instead of that, this aromatic ring broken. Secondly, oxidation means electron withdrawing nature, means oxidant will withdraw electron. So consequently, if you look at this molecule, when this CF bond is very strong and it is almost impossible to break, then what option left? Electron rich part, that is the benzene ring, and that's why only 1 carbon left from the benzene ring. So CF3 is here, this is from side chain, and 1 carbon from the benzene ring, so it produces this trifluoroacetic acid. Okay, so answer of this question is trifluoroacetic acid, or option B. Now question, why not other? See, for example, acetic acid not possible because CF bond energy is very high, so it will not be destroyed, it will not be broken. If I say that, then since I have started from this CF3 in the side chain, so in this case CH3 not possible. CF bond breaking is very difficult. Okay, and another thing, in this case no reaction, although that's not true because reaction will happen. So this is the answer. So thank you.